This is a video about the coordinate geometry of the line with a focus on slope. So what is slope? Slope can be thought of as the steepness of a line, or the rate of change, so how much it's changing as you travel along it, by which we mean how much is it going up or how much is it going down. When we look at a line, we always imagine that we're looking at it from the left-hand side of the page. So when we read this line, we can see that it's sloping up. A line like this has a positive slope. We can say that this line is increasing. This line is sloping down if we look at it from the left-hand side. And so we can say that it has a negative slope, or we can say that the line is decreasing. This line is horizontal, so it's not sloping up or sloping down. So in this case, it doesn't have a positive or a negative slope. We can say that it has a slope of 0. And it's neither increasing nor decreasing. Here's a little bit of notation. The letter M is often used to represent slope and coordinate geometry of the line. And there are two other symbols that we also frequently see in relation to slope. This symbol looks like two lines with the same slope, and it's the symbol for parallel. This symbol looks like a pair of perpendicular lines, and it's the symbol for perpendicular. If two lines are parallel, their slopes are equal. So the slope of the first line would equal the slope of the second line. If two slopes are perpendicular, or if two lines are perpendicular, the product of their slopes is -1. We can calculate slope in two different ways. If we have 2 points, we can use the formula y2 minus y1 over x2 minus x1. This formula is on page 18 of the log tables. If I have a graph with a grid, then I can find the slope by finding rise over run. Let's look at an example of how to calculate the slope using the formula from the log tables. So we want to find the slope of the line that passes through 2 points. A is the point 2 minus 3, and B is the point -1, 1. There's a few things that I should do first. I have 2 points, so I want to use the formula. So I should write the formula down. I should also write my 2 points down, and I should label them. And I should always label them x1, y1, x2, y2. So now I'll set myself up to fill in my slope formula. So m equals, on the top, it's y2 minus y1. I can go and find y2. y2 is the one that I've labelled here at the end. In my formula, I can see that there's a minus in the middle of the top line of the formula. So I'll fill that in. And then next, I fill in my y1. Now notice here my y1 is -3. So I've got a double minus here on the top. On the bottom, I've got x2. I can go and find x2 in my points. It's -1. I've got a minus in the formula. And my final entry is x1. And x1 is just this value here, 2. I can fill this entire calculation straight into my calculator in one go. And when I press equals, it'll give me my final slope. And in this case, my slope is -4 over 3. Notice that it's a negative value. That means that without even drawing a graph, I know that the line that joins A and B is a decreasing line. It will be sloping downwards. Next, let's look at an example with a graph. So here's my diagram, and I've got my line here in pink, and I've clearly marked in 2 points. Notice that the 2 points that I've marked are on the vertices of the grid, by which I mean they're in the corner of a box in the grid in each case. Okay, so I want to use this graph to get the slope of the line. So I want to find the rise and I want to find the run. And the way that I do this is I'll draw in a triangle that connects the 2 points that I've chosen. I make sure that the triangle that I draw in goes along on the grid lines. Okay, so now the horizontal distance is the run. And I can count here 1, 2, 3, 4 boxes across. My run equals 4. The rise is the vertical distance. In this case, I'm going up, so it'll be positive. And I can count the number of boxes, 1, 2. So the rise equals 2. I'll note that slope is rise over run. In this case, that's 2 over 4. And I can cancel this down to a half if I like. Next, let's have a look at parallel lines. Here we see a statement, AB is parallel to CD. AB is the name of a line. It's the name of a line that passes through 2 points called A and B. CD is also the name of a line. It's the name of the line that passes through the 2 points C and D. In this example, the slope of AB is 2/3. And the question is, what is the slope of CD? You may remember that earlier in the video we mentioned parallel lines. What did we say about them? Parallel lines have the same slope. So now we actually know the slope of CD. If AB and CD are parallel, then they must have the same slope, so the slope of CD must also be 2/3. Now let's look at perpendicular lines. The line AB is perpendicular to the line EF. I'm going to use the same slope as in the last example, so the slope of AB is 2/3, and I want to know what is the slope of EF. There's a really nice quick trick to figure out the slope of a perpendicular line. So if I know that AB has a slope of 2/3, and I know that EF is perpendicular to it, then to get the slope of EF, all I have to do is flip over this fraction and change its sign. Now, flipping it over, it's going to be 3/2, and changing its sign, well, at the moment, this fraction is a positive fraction because there's no minuses in it. And so when I change its sign, the slope of EF must be minus 3/2. You might remember that earlier in the video, I said that if two lines were perpendicular, then the product of their slopes is -1. So I can check and see if this is true for these two lines. I can multiply my two slopes together, and I can type this into the calculator, and when I do, I get a result of -1. This is a useful little trick to check if two lines are perpendicular.